Good morning, everybody. So I'm going to start this session. I think that we have here three very interesting presentations. It's a theme that I really enjoy and like to learn about, because how to make people work together over the network, how to promote this collaborative effort is a thing that is more easy to say than to do. And so I think that we will learn a little bit about this with our presenters. The first presenter will be Viviane Paz. Viviane has over 25 years of experience in the IT industry in Brazil and Australia, including the higher education and career sector. She'll be presenting a paper about the research data storage in Australia.
Thank you, João. Can you hear me properly? Yeah? Great, because my voice doesn't project that much. So, well, thank you to the program committee for having me here. It's an honor to present at TIRENA. The last time I've been to one of the TIRENA conferences was probably about 7 or 8 years ago, and for my surprise, guys, have you grown? This is just amazing. It's a great conference. So, but I'm here to talk about the RDSI project and how we actually have changed a little bit how research data is stored in Australia. So we'll go through the situation that we had before RDSI, then look at the project and how we actually got through the project and what we have implemented. So the funds that we received for this project are still a residue of an initiative called Platforms for Collaboration that started in '97. And it continues until, well, went up to 2011. So the intention of the federal government in Australia was to see what can be done to help the researchers to do their research better. And one of the aspects that had to be considered is the infrastructure for them, so they can focus on research as opposed to having to focus on the infrastructure themselves. So that's a little bit of background. Also, before we started the project, they assumed that we would need about, or would have collectively in Australia, about 5 petabytes of research data. You'll see later that that's not the case. But then why invest money and why do this? Well, the main idea is that the government wanted the information to be able to be shared more. They wanted to make sure the research that is done in Australia gets the credit for it. We had some occasions in which research was almost lost, well, was lost and then found, but researchers almost lost the credit for what they have done. So focusing on research data and being able to ensure that it's accessible, secure, and not just accessible by the small group that is doing that research, but making it broader was one of the points that the government made.
Research data is like intellectual gold. Everyone wants it, but accessing and sharing it, well, yeah, it's a battle.
Can you stop it?
Sure, the world's getting smaller in many ways, but large amounts of critical research data have either been too slow.
Sorry, didn't mean to get it going that fast. Meant to explain what this is. So, as we started the RDSI project, we've consulted a lot with the community. That was one of the main things that we had to do, to bring everyone along. And to make sure people could understand in an easy way, we created a small video, less than a minute. Are you able to bring it back for me to the beginning? No? So maybe I can do it here.
To access.
How about it? Just do that. So it's less than a minute to explain to researchers, to the community in general, what was that we were building, because we weren't actually building something simple. It's extremely complex. So trying to simplify it.
Research data is like intellectual gold. Everyone wants it, but accessing and sharing it, well, yeah, it's a battle. Sure, the world's getting smaller in many ways, but large amounts of critical research data have either been too slow to access or too hard to find in the first place. Oh, well, that's until now. Introducing the Research Data Storage Infrastructure Project, or RDSI for short. Now, this data storage framework will let you securely store and access large amounts of research data from all over Australia, faster and easier than ever before. RDSI are funding data centres, or nodes as we call them, all across the country, and a secure, high-speed network will make it fast. Researchers can share, collaborate and reuse their results, which means less duplicate research. And with access tools specifically designed for different disciplines, finding exactly what you need is simple. It's fast, it's secure, and it's cost-effective. So stop searching for the proverbial needle and start storing and accessing your research data smarter. To find out more, visit rdsi.edu.au. It's accessible research data made simple.
Well, now my work is done. No, just kidding. So in 2011, actually late 2010 was when we received the funds. The RDSI project started, funded by the Australian federal government. We received 50 million as part of the National Research Infrastructure for Australia. So you'll hear about ANCRES again later. So don't expect you to read this, but what we were expected to do was to create a national research cloud. It had to include the infrastructure of universities or the research, so that was part of it. It had to have a very high-speed network between the data stores, or between the nodes, as we call them. And we also had to ensure that the data that was stored in there is actually of national significance. We didn't want to have any scrap data. We wanted to have real data in there. And while we were at it, as if we didn't have enough complex things to do, we also had to encourage economies of scale by creating a vendor panel, which we did quite successfully. So all of these objectives have been achieved quite successfully. So how did we do that? We did do that via 4 programs, and I'll jump straight into them as I explain them a bit later. So the node development program, was one of the first ones, was really to create the data centers, to create the nodes, or better yet, to find which ones would be part of it. So at the end, what we did was we did a call for participation, and a number of organizations came forward. A lot of those organizations, if you look on the map, like QCIF and Intersect and TPAC, they actually are supported by the universities of the state that they belong to. So QCIF is in Queensland, so all of the universities in Queensland belong to QCIF or are members of QCIF. Same thing with Intersect in New South Wales. So those organizations came forward, put their proposal. Besides the 50 million that we received from the government, we also had the co-investment from the nodes into building the infrastructure. So we built the data center, we funded the building of these data centers. We had 6 primary nodes and 2 additional nodes. The only difference between the 2 are that the additional nodes, at the time, the network, we couldn't actually get the physical network to them as fast as we can with the other nodes. So the QCIF Townsville and the TPAC in Hobart are the additional nodes, while the other ones are the primary nodes. So the next oops, went backwards. Let's try again. There you go. Right. The Research Data Services Program was possibly supposed to be the easiest one to implement because basically it was for us to obviously we had to identify lots of procedures and mechanisms to put things in place, but we had to identify data collections that were of importance to nationally. And the way we had to identify was not us as in RDSI, but the community with the nodes. So what we did was we helped the nodes to create the merit allocation committees. And those merit allocation committees have members of the disciplines and members of the universities. And they are the ones that actually decide what is meritorious to the country and what is not. We also funded staff at the nodes because as we moved forward with the project, we realized that we did not have the data storage skills in the nodes that we required. And obviously, hiring people is not that cheap. So we were able to actually facilitate that and fund 2 staff at each of the nodes for the period of the project. And that was to help with ingestion of collections and also to develop the node infrastructure per se. Some nodes actually already had their infrastructure in place and just add to it, and others actually had to build things more from scratch. The previous program, I said, was the easiest, should be the easiest one, but it was the more political one as well because it involved money, and you can imagine how that can be. The data sharing program, however, this was extremely complex to deploy. And at the same time, our sponsors didn't realize that this was actually the hardest part of the project. So the data sharing program built the glue that put it all together between the nodes and in each node. So it's split into components, the Dash technical architecture, and also the Dash collaboration network, which is the DashNet. So the DashNet was really funded by the National Research Network project, managed by RDSI, but implemented by RNet. So RNet did a brilliant job for us, providing the high-performance network that we needed between the nodes and helping us to do a few more things that I'll talk about just in a minute. So the Dash technical architecture then had a number of components, and we had, for example, the test platform in which we, as in collective we, our stakeholders, including nodes, RNet, AF, vendors, had to look at technologies and options to be able to implement the infrastructure that we needed. We also looked at automating the workflow for the allocation resource management system, which was created, which is called ARMS. That way, when a researcher or a data custodian wanted to have their data stored at this RDSI-funded infrastructure, they would then be able to fill a form electronically, go through the merit allocation committee, and they would just go, tick, that's good, get it all ingested and get it started and using. We also looked at public cloud access, and we connected some nodes with Amazon at the time, but it applies to any cloud, because we were thinking of the future, what will happen after, in a few years to come. And security was one of the big things that we had to look at, so we developed security policies and guidelines for the nodes and the universities in general. And we also ran workshops with each node to discuss what their issues were, what their concerns were, and what could be resolved and how they could resolve them. We also looked at data access mechanisms. It turns out that the data access is a lot more complex than we expected from the beginning and the nodes expected from the beginning. And what we did is we ended up looking at tools that were already available and also looking at developing data access mechanisms that the researchers needed. Depending on the discipline, you might need a different data access, so one shoe doesn't fit all. But one thing that we did that suited all of the nodes was using media flux as a data management system. We also used the Australian Access Federation for the identities to be able to log into to the nodes and to the data. We used the DashNet that I just mentioned before, and with the DashNet, we implemented a science DMZ. I don't know if you went to Eli's presentation yesterday. He explained all about that. And if you want to know more about it, how it was implemented on RDSI, the best person to talk to is David Wild, which is presenting at the moment in another room. We also had to move data, and a lot of data, and we had to move it fast. So we looked at tools that could help us, and one of the tools that most of the nodes found very useful was Aspera. So we have actually bought licenses for all of the nodes to continue to use that. This slide's not mine, it's from RNet. Basically, RNet, it's not that RNet created a different link to what they had, they just built more capacity for us, using RNet 4 to be able to have more redundancy for the nodes. And we have 2 10 gigabit links, which is actually pretty good for what we have in Australia. So in terms of outcomes, we've talked about some of them. The only ones we haven't are the monitoring and reporting at the end there. Basically, when the nodes develop their node, we monitor from a border perspective, a border network perspective, to make sure the nodes are available or to see how much downtime or uptime they have. And also, with reporting, is actually the nodes telling us what they have actually been doing. I have a few slides that show, in terms of ingest and allocation, how the nodes are positioned at the moment. So the fourth program was the vendor panel program, which was very interesting to build. We had legal helping us. We developed model contracts. We put forward this call for this RFP, request for proposals, and we received many from many organizations, and the vendors were not just for data and storage, they were also for services. So why did we do that? Well, we wanted to get the best price we could for the nodes and the higher education. Also, we wanted to make sure that the universities didn't have to tender. In Australia, if you're going to buy something, you've got to go through a tender process. And tender processes are expensive. So with doing this, we reduced a lot of tendering around Australia, which was great. And we did that with Quadit because, I don't know if you know, but Quadit is the council for the Australian IT directors. And Quadit has a lot of experience with procurement and mass procurement because they have, all of the universities are members of Quadit plus a few other research organizations. So the main outcome of our project was that we funded and facilitated the creation of this very large and new collaborative network of nodes. And doing that, we supported better managed and more accessible world-class research data in Australia. At the time when we started the project, we looked around and there was absolutely nothing that we could find in terms of an infrastructure around in the other countries that had built a research cloud for the whole country. So that was a very interesting thing to go through. So it was an extremely complex project, but extremely interesting to do. So at the moment, we have more than 23 petabytes stored, ingested, and available. And you can see the different nodes. The red means what the researchers can get to. The gray means what the nodes told us, that their merit allocation committee is already allocated to them. It's just under 50 petabytes, but they actually have storage enough. The storage that we funded is equivalent to 100 petabytes of raw data for the nodes in general. So they've ingested more than 53%. But one thing that is quite interesting is we have 22 fields of research in Australia, and we always wondered from the beginning of the project how many of the disciplines will actually come on board. And we were so pleased. All of them came on board. All of them have actually put some of their data in one of the nodes. So this diagram shows collectively what all the nodes ingest. Some nodes are more specialized in astronomy, some are more specialized in health or science. But this is collectively. So the biggest one, obviously, is earth sciences, as we would have expected. And then we even have philosophy and religious studies that have actually been stored on this research cloud in Australia. So what happened after we finished the project? Because we finished the project. So basically, we have transitioned a number of aspects of the project to our partners and our stakeholders. So obviously the nodes are working with, continuing to preserve the legacy that we built. ARNet continues to support the network, coordinated with the vendor panel. They actually took it on, and they will continue to support the vendor panel because we're so successful. And the AAF helping us with the identity of our researchers. There we go. One of the most rewarding things that we had was that we went and interviewed a number of researchers that had their data in the RDSI infrastructure. And the feedback that we got was extremely positive. And a lot of the comments were, this is great, because now I can focus on doing my job, which is research, and I don't need to actually spend any of my grant money on storage, which makes sense. So I'm quite pleased we've done that. And we have a number of stories. It's all on our website. Those are just graphic images of our stories, and involves the SKA, involves the genome, involves the weather and climate change project. There is another project that is a global survey, like a spatial survey, in which they look at weather patterns and sea rising and everything to then analyze that and see where the crops and which types of crops could be planted and where, which is very interesting research. So a lot of these stories that we have are extremely useful information to be kept. And the main idea for doing that is to be able to empower the researchers to open this data more to the other researchers as well, and collaborate more, share the data. Also, this expectation is that perhaps people looking at the data from a different perspective might be able to make new discoveries. So what's next after this? Remember I mentioned about the NCRIS. So NCRIS continues to exist, and they are funding a little bit more, as you can see. So there are 27 capabilities within NCRIS. The blue ones are directly related to RDSI in one way or another, either being sister projects or nodes. Oh, sorry, I forgot IMOS as well. As part of DPAC, the funding that the RDSI project received was a funding that could only be used to build and develop things. So we could create infrastructure, but we could not operate infrastructure with those funds. This NCRIS fund that is coming out now, actually came out last year, but it's over 2 years, it's funding to actually do the operational side, which is excellent because then it helps the nodes to continue to provide the services that they have been providing before. This one. So while RDSI provided the infrastructure and foundation and created this high-speed data cloud, which has a better way to manage data and provide access to researchers, it also created a side effect of building skills levels in Australia with regards to data storage. And it also changed the way researchers look at where their data needs to be. Because initially they thought that their data had to be with them sitting under their desk or whatever, as close as possible to them so they could physically get that. Now it's not so much like that. Obviously not all researchers have put their data over here. This is a work in progress and the nodes will continue to do that. But that was a foundation and it's a legacy that we are leaving behind. So the future is the research data services, which is focusing in turning data storage into services for the sector. And I thank you very much for your attention. Are there any questions? I'll be at the conference, throughout the conference, so happy to chat later as well. There is someone at the back there.
Hello. It's a very nice and interesting project, what you explained. What I'm thinking, so there's a lot of people are putting their data inside of this infrastructure. Are there any reference to the author of the data? So the owner of the data is always known, or how you manage this?
Yes, there is. That's actually part of what ENS has been doing as well. So the metadata information. Yep.
Thank you. Hi there. Have you been working at all with the shared access research ecosystem in the United States that's working on sharing of research data?
We, as the RDSI project, directly no, but I'm pretty sure some of the researchers in Australia are.
Okay. I'll send you an email because I currently join their board, and so I'd like to collaborate a little bit.
Absolutely.
That's great. Thank you.
Yeah. Welcome.
Well, just a quick question. I don't know are you at the point where you start to have some indicators about the reuse of this data? So now the data is out of the labs, so it's accessible, it's in a common vault, and now it's a great opportunity for researchers work on this information. Do you have any indication that this kind of project increased the reuse of research data?
We have some evidence of that. What we expect is, as it progresses, because the nodes are still ingesting a lot of data, that will become a lot more clear and visible in the future. Any more questions? No? All right, well, thank you very much.
Thank you, Viviane. And now to our second speaker, Nicole Gregoire. Nicole is a technology and policy advisor at SurfNet. She started at SurfNet in 2010 as a community manager research. She will be talking about the SurfNet project, about research innovation.
Good morning, everyone. Well, Joe already introduced me. My name is Nicole Gregoire from SurfNet. And the title of this talk is Innovating Together, which I've thankfully borrowed from last year's TNC theme. This presentation focuses on the necessary ingredients for successful science engagement. These ingredients follow from the lessons learned of many activities that SurfNet undertakes in the area of user participation. I will start with sketching the context in the area that we act. First, we have us, the NREN, and in most cases we are working together closely with the IT departments of the institutions who aim to support and maintain the ICT needs of their users and staff. And in the corner, there sits the researcher, whose goal for life is to do research and write papers. Our goal, the SurfNet's goal, is to innovate together with the IT departments and the end users. We do that via push and pull. We push new technologies and we pull user demands. And that sounds easier than it is. Pushing new technologies that are on the leading edge takes a lot of confidence about the usefulness of the technology. The uptake may take ages and may never reach the long tail of the users. Pooling user demands is a very time-consuming task. Users can tell you exactly what they need right now, but are less outspoken if you ask them about their future needs. Furthermore, to truly innovate together, you need commitment for a longer period of time, which is hard to get from busy people whose goal for life is to do research and write papers. So, how do we get an end user's attention? Well, I don't think playing hard to get works in our area. But as an NREN, we do need to think of ways to get researchers involved in what we do. Some NRENs have special departments for user participation. At SurfNet, we have 3 so-called community managers who are responsible for the outreach and the support to Dutch research community. ESNet has a department called Science Engagement. I really like that term, so I will use that also in this presentation. In order to innovate together with the researchers and the IT departments, SurfNet needs to know who those researchers are. For the past decade, we have tried really hard to engage researchers with what we do. We launched a so-called Support for Research program to promote what SURF can do for research and to support researchers with the use of the ICT facilities that SURF offers. A very successful concept to engage end users appeared to be the competition concept. Winning an award looks very good on a researcher's curriculum vitae. We have organized competitions for many years now, and our most well-known competition is Enlighten Your Research. I'm sure many of you know the details of Enlighten Your Research. We have presenting about it for years now at TNC. And with Enlighten Your Research going global in 2013 and in second edition this year, the program has become well known among NRENs around the world. But after 5 subsequent editions, we believe it is also time to draw up the balance. What have we learned? What have we gained? What should we do differently with forthcoming editions? And most importantly, what advice do we want to give our fellow NRENs that want to organize their own program? Enlighten Your Research started 7 years ago to create awareness about the possibilities of LightPass among researchers and to stimulate their uptake. In later versions of the competition, we included the bandwidth on demand concept. Soon we encountered lessons learned number 1. With respect to infrastructure services, researchers are the least interested in advanced network services, for example, LightPass. Bandwidth is not on the first page of a researcher's priority list. In general, researchers are not primarily interested in infrastructure. A researcher's primary interest is doing research. During their research project, researchers gather data. These days, often loads of data. At some point, they will become more interested in how and where to store the data, how to process the data, and how to transfer the data. Once they want to scale up, they are first facing problems with lack of storage capacity to store their overload of data. After that, the lack of computing capacity to offload their personal computer and to speed up their analysis. Since they often do not need these services real time, their regular internet connection is sufficient. But as an NREN, we want to push the limits of network innovation. And to do so, we do need input from our target community. So to make them interested, we joined forces with other e-infrastructure providers and offered integrated solutions, including ICT services that are higher on the list of a researcher, such as storage, compute, and support. This actually worked. The latest version of the Enlightened Research competition, the national competition that ran in 2013, attracted 18 research groups. From this follows lesson learned number 2, collaborate. Either with partners that get you closer to your target community, or collaborate with partners that help your target community to extend their own collaborations. One of our sister organizations in the Netherlands, Surfsara, offers its compute, storage and visualization services directly to the end user, and is therefore in direct contact with them. In the third and fourth edition of Enlightened Research competition, we joined forces with Surfsara and offered a combined package of infrastructure components. In most cases, the researchers had been initially attracted by the storage and compute services, but because of the Enlightened Research program, we got them at the table, learned a lot about their networking requirements, and were then able to give them better advice about the most optimal network solutions for their research. Also, we have experienced that the demand for international light paths is much higher than for national light paths, well, mainly because of the Netherlands, that is such a small country. This inspired us to organize Enlightened Research Global in collaboration with other NRENs. Researchers often do not know which e-infrastructure services are available and, moreover, which ones are best suited for their data workflow. So hence, lesson learned number 3. Take time to talk to each other and find the best possible solutions for their data challenge. This step should not be underestimated. It takes time to learn the precise workflow of a research project and the technical requirements that can be derived from that. Make sure you understand the research problem before you start with the implementation. Not only the researcher should be at the table, but also other people that have a role in the project, such as network engineers, security officers, and other ICT staff. For researchers, a much appreciated part of the award was the support they get with the implementation of the infrastructure services. And they need a lot of support. We cannot simply hand over a bunch of fibers and wish them luck. So lesson learned number 4, in order to make the infrastructure project a success, researchers require end-to-end support. And communication is a key factor in the whole process. This includes communication between all the research partners, not only within one institution, but between institutions as well, between the researcher and his local IT department, and communication with and between service providers and the other NRENs. Lesson learned number 5, manage expectations. Well, you always have to manage expectations, but we experienced that we needed to be very explicit about the continuation of the project, especially when the period of free use was over and money became an issue. Make sure researchers continue to use the service and stay involved in the development of the service. So, in addition to what is in the paper we submitted to the TNC, I have also a bonus lesson. And this is something that we did not very well in our past editions. Make clear what you expect from the researchers. So, especially with the competition concept, it's maybe all about giving. We give the researchers support, we give access to services. But of course, we want something in return. We are organizing the competition and we want something as well. So, but make sure in advance that you know what you want to get out of the collaboration with those research groups, and make sure that you communicate that with all the parties involved. So to summarize, after all our activities with the research communities, all those years that we worked together, that we did science engagement, what did we learn? Summary, offer an integrated solution so that they are also come for the network services, collaborate, communicate, make sure you understand the research problem before you start with the implementation, get everyone around the table, not only the researcher, but also the IT department, also other providers of infrastructure services, and keep them around the table. Manage expectations, and make clear what you want from the researcher. So although the goal is to innovate together, we experience that the end-runners need to put a lot of effort, time and effort, in engaging the end user in our activities. So what is in it for us? What do end-runners get out of it? Well, the best thing is you do get closer to the end user community. You come into contact with early adopters, but also with early and late majority adopters in science. But it takes a lot of time before they are willing to interact. And of course, there should be something in it for them as well. Do not expect the end user to put energy in further developing your services if it does not benefit them immediately. But once the partnership is established and all the parties are committed to the project, the development of services can take major steps. We often see researchers coming back to us for new projects once they have experience working with us through Enlighten research. We are going to continue with Enlighten research and engaging the researcher. In fact, the call for proposals of the second edition of Enlighten Research Global just closed, and in 2016, the fifth edition of Enlighten Research National were won. One of the main reasons for continuing is that we see value in the interaction with the researchers, the ICT departments, service providers, and all the parties involved. The researchers and institutions involved do not only learn from this experience and get to adopt the services, but we get to learn a great deal in many ways too. Whoa, I'm fast, I guess. My presentation ends here. But if you are interested in more science engagement and want to share your experience or talk about opportunities to collaborate on a global scale, please visit the Science Engagement Roundtable coming Thursday morning. Thank you very much. Questions?
This question is not posed to you because this is a much more general question, but your presentation did provide an opportunity to come out with it. Everything is fine what you were talking about, and these requirements with respect to the communication and cooperation between the service provider and the user, the researcher, perfect. But we have 50 million users in Europe. How to do that? It is practically impossible to contact 50 million users, to understand their problems, to follow, to talk to them, and so on and so on. The question is to be answered, because if we look around, everybody is looking at us and are waiting for the answer. Please, infrastructure provider. There are the users, please solve their problems. And sometimes we can't do anything but just say, we have very important big users, the big projects, and we don't have more staff, more people, more capacity, more energy to answer the others' requests.
Yeah.
One possibility, by my feeling, is to somehow classify the user community and to try to find the answers to their problems by this way, but I don't yet know how. Thank you very much. If you have something to add, thanks.
Yeah, that was especially, that would be my solution as well. We have in the Netherlands, we have the Netherlands e-Science Center, and they have divided the research community in domains. and have appointed key people in those domains. So people who are willing to think about e-infrastructure and are in contact with the majority behind them. And so indeed you cannot talk to everyone. You need key people in each area to talk to. But then again, you also need a lot of time in trying to figuring out what they want and also help them figuring it out because they don't know it themselves. Yes, that they do the requirement sessions. So they are, every 2 years, they sit around the table with one domain and with a lot of people from that domain, and then they have a whole morning or a whole day or maybe 2 days where they talk about requirements for their research, and they start from the research problem. So and the research and the outlook where research is going, and then they deduct the solutions from that. And I think that's a really nice approach, but it is really time consuming. So. But this will also be a topic at the Science Engagement Roundtable, to do it maybe more globally and to extract those requirements on a global scale. Also, although we do then have even more use, but maybe we can, somehow integrate them and follow it.
Can you tell us where is room number 11A?
Oh, I meant A. It was session 11, room A. The 11th floor. No.
Sorry, I also want to make a short comment on this. I'm from Austria, and we are running also in Austria a project that's now for 1.5 years called E-Infrastructure Austria. And we also want to focus on the researcher, and we have the same problem. We cannot go to every researcher. But what we have done a national survey and ask every researcher, or in the survey it's gone to the researchers, and ask them what they expect us to do for their infrastructure, what the kind of data they are doing, what kind of research they are doing, what's for them research data, and what they want from the institution that they built the infrastructure.
Okay.
And the outcome will be, I think, hopefully in this fall.
Okay.
And
it would be nice to share.
yes, it's the outcome will be also open access, and I can also provide links of this if you're interested.
Okay. And have you already seen some results, or is it still running?
It's still running, and we have made some assumptions before, and what we have seen, we are not completely failed with our assumptions. So we see there is a lot of big data, but there are some special fields that they have big data, and people from the humanities are really far ahead in archiving data. And also, what I want to say, I work with this e-infrastructure project is situated not in Austria by the IT departments, it's situated by the libraries. And I'm a connection between the libraries and the computer center because I'm working at the computer center. And so I also think it's necessary to work closer together because both were asked to build infrastructures.
Okay. I have just one practical question. How did you get to manage all the email addresses for all the research? Because we cannot gain access to any contact details. So
we are very lucky with this project because in this project every university in Austria participated.
Okay.
And we done this survey locally. So we sent it to our participants and asked them to ask them their research because they have all the lists.
Yeah.
We have not centralized.
I think it's the only way that it works. Yeah. Okay.
Thank you for an informative presentation. My question is around your lesson learned of what do you expect from the user or the researcher? Can you elaborate on that a bit? What kind of things did you expect and how was the response?
Okay, well, as I said, we want to interact with the user because we want to innovate our services. We want to know what are the requirements for our future services. And in the end, we did not make very clear that we needed time from them to do that with us. So that we gave them our services at the moment that they could use it, but we did not ask them to be involved much longer to also develop the service further. So it was all about the competition and the award for them, without specifying very explicitly, okay, but we also need something from you. We want you to be involved in a user group and come every 2 months to our office and evaluate one of these services or one of those GUIs or something like that. So we did not really specify that, and then they say, we don't have time for that, or we don't do that, or so that was. We need to do that more because otherwise we do not get anything out of that other than the requirements, but not involvement in the process itself. So.
Thank you.
Thank you. I'm from Internet 2 in the US, and one of the things I've been hearing from the universities as well as some researchers in our national labs is that the researchers need like a starter kit to learn how to use the network and how to connect to it. Like sometimes they don't know it's there, or they know it's there and they don't know how to get to it. Is it magic? Does it just happen? So we're thinking about what that would look like, this starter kit capability. Do you do something like that, or have you had the request for that?
We have that support for research program, and that launched 2 years. We started with that 2 years ago, and one of the goals is to have to have a kit like best practices. How do you use this? What is available? And also we do roadshows, so we go to the universities, but we have only 14. But we go there and then talk about our services, and we do that in collaboration with those storage providers, compute providers. So not only from our network perspective, but the whole infrastructure.
So do you have a starter kit that you could share with us?
No, not yet.
Not yet, and you've been doing this for 2 years. So it's going to be hard. Does anybody here have one? Any of you guys have a starter kit for researchers to use your network? Looks like we have an international opportunity here.
So we have some information already on our website, but most of it's still in Dutch. So we can share it, but it will not be of use to you yet, but it will be translated.
So why is it so hard to do?
Also because everything is still innovating, right? It's an ongoing process, so you need to update the information all the time. So that's basically why it's hard to do. So it's never finished. It never will be. But once we have a good set in place, then we can share it.
One thing we had to do was we had to work really closely with the IT departments because they didn't want us to go around them and go to the end users directly. So that's why we had to visit all those universities as well to discuss what can we do directly, what do you want to do together. And of course it's okay because they have a part in the process as well. They are also delivering services to the end user. We are not the only one, so we do work together. But that was one of the reasons that takes such a long time to have that whole field and whole overview ready.
So perhaps out of the Science Engagement Roundtable, we want to create a little international working group around this. Like maybe if we hold hands, we can get there faster?
Actually, that was going to be one of our suggestions during the roundtable. So, so come to the roundtable.
Okay, thank you.
Well, thank you, Nicole, and your shorter presentation gave us time for this lively debate. That was nice. Now we'll have Michael Enrico. Mike, in 2001, he joined Dante, Network Engineering and Planning team, and in 2012 was appointed CTO and now is responsible for developing network-related technology strategies in the new JN Association. And we'll be talking about JN open calls.
Okay, so good morning, everybody. I'd like to thank the Programme Committee for giving me the opportunity to talk about the Géant Open Call this morning. So as you can see, my name is Michael Enrico. One of my roles in the GN3 Plus project, which has just finished, as a technical or JRA, Joint Research Activity Coordinator, so I've been involved very much from the technical side of the Open Call programme that I'll tell you about this morning. And my colleague Annabelle Grant, who sat here in the room, she deserves a lot of the credit for bringing this programme together and driving all of us to make it work, and the participants. So if there's questions at the end, then I will do my utmost to answer them, and Annabelle will help me along as well. So I was quite interested to see the plenary this morning, in which the first speaker talked about his graph theoretical analysis of the environment and the conditions it takes to promote innovation. And I hope in some small way I will show you that we've kind of achieved some of those conditions with this Open Call project. So let's see how that goes. Okay, so right then, so I'll tell you a little bit about why we did an open call process. It's pretty obvious, actually. One of the first reasons for it is that we were obliged to do so by the European Commission as part of the grant award for the last project. But there are other reasons as well. A little bit about how we did it, so describing the programme, and I want to dig into some of the results as well, if I can. And then I'll talk a little bit about the continuity, what's going on with respect to some of the results of that work. I'm not really going to be in a position to tell you about the next open call, because at the moment we're trying to work out when and how that will happen, but maybe we'll have some discussion at the end on that matter. So a quick recap. An open call as we have conducted it here is an EC process for openly selecting and bringing new partners into an existing project. In our case, we were required to spend 50% of our joint research activity budget on this particular open call. As a result of that, as you'll see shortly, we selected 21 projects to take part, to join the overall GN3 Plus project. And the budget for that was about 3.3 million euros of EC money, with additional funds, because these are co-funded activities brought in from the partners. And this included a whole lot of new partners who've not really engaged in the Géant project before. So here are a few of the logos of those partners, and you'll see some large and small commercial entities there, research centres and universities. So there are two other good reasons why we did this open call, and one of them is fairly obvious. We need innovation to keep the Géant products and services world class. This logo here is meant to show what may be a slightly apocryphal story here, but the video and DVD rental company Blockbuster supposedly had a chance to buy a kind of startup company, video distribution company years ago called Netflix, and they didn't, and Blockbuster no longer exists, and we know what's happened with Netflix. So innovate or die is the message there. It's one of the good reasons. And the second one is that it allows us to open up the box, to leverage expertise outside of the traditional Géant project players, and bring in these new partners with new ideas. Make them work. This is an important point. Make them work with those people that are already in the project. And as I hope, as I'll show later on, we kind of end up with some generation of nice, innovative results. So we started from more or less a blank sheet of paper here, not quite a fully blank sheet of paper, other than the fact that we had to spend 50% of our R&D budget on this program. And there were a few sort of high-level program objectives from the beginning, so here they are. First of all, we wanted to ensure that our products and services remain world-class and enhance the ability to do that. Secondly, to push the state-of-the-art at innovation in research and education networking. Thirdly, to enable and stimulate the use of the GÉANT facilities, the infrastructures that we already had available. And fourth, to raise a GÉANT profile at the European and global level based on these three objectives. So those are the high-level program objectives. So to do that, after a lot of discussion within the project, within the GÉANT project, we put together a program that looked a little bit like this. So we had a set of themes and more detailed topics. Theme 1 was to encourage use of the facilities. These included some spare dark fibers we had available, most importantly, the software-defined networking facilities, testbed facilities we had available. So that was essentially the item to encourage researchers to come in and use the facilities we had. By the way, as you'll see here, many of the messages I'm going to tell you are very, very similar, if not identical, to what you've just heard from Nicole with respect to the Enlighten Your Research program. Unsurprisingly, there's very little difference in the way of the motivations and what we can get out of this. So the second of these high-level themes was to undertake what we call focused research and development. So this is where the partners who were already in the project, who were responsible for the research element of the project, they identified pieces of work that they'd like to see done by these new partners. And so they put together a whole set of topics here, and that went into the call text that was published as part of the original open call. So they were divided up more or less into three areas: network architecture, technology testing, and identity and trust technologies, and they relate to the three research activities within the project, covering those same areas. And then we had a third theme, a kind of wild card theme. So this is where we essentially said, okay, tell us what you want to do. This is the open innovation topic. I mean, it wasn't fully open. Obviously, it had to be research and development work of relevance to research and education networking infrastructure and the services it provides. So that was the open innovation topic. Right, so the most popular of these topics, it turned out, essentially in terms of the number of bids that came in, was the making use of the testbed facilities. In total, we had something like 70-odd projects bid in. Was that right, Annabelle? 70-odd projects. And the available budget was oversubscribed by a factor of 3 to 1. But this is how we ended up spending the money across those three broad themes. So 15% went on the innovation topic in 3 projects, 32% on the use of facilities in 7 projects, and then 53% across this research, this outsourced research element there. So an important part of how we then conducted the open call program was to make sure that when we brought these new partners in and they started their work, was to make sure that they were integrated into the project as fully as they could be. So there was 2 aspects to this. We wanted to make sure that they were administratively integrated into the project and then technically integrated into the project. So this is what I'm going to try and show in the next 2 slides. You can't really see this, but this is screenshots from the GÉANT intranet pages. So we made sure that as far as the integration here, administrative integration was concerned, we made sure that they were made to feel at home from the very beginning. We gave them full access to the intranet. They all had their own intranet pages. They could access other intranet pages. Each project had its own set of pages. They were on mailing lists and received all the communications. They were invited to one of our annual symposia to present and put into relevant topic-specific project meetings, so the ones that were related, for example, to the joint research activity number 1 on network architectures. They all made sure that they were engaged with them. So we really went to a great deal of effort to ensure that those participants felt part of the wider Géant community. Annabelle and her colleague Natalie in the Cambridge office spent a lot of time bringing them in. I'm sure Annabelle has got plenty of stories related to that. So the second aspect was the technical integration. So this shows another way in which we subdivided these 21 projects into topic areas. So as you can see, there were 6 in the area of software-defined networking, 4 in the area of what we called applications and tools, and I'll come on to some examples of what went in there in a moment, 6 in the area of authentication or trust and ID related work, and 5 projects up here in this box in the top left relating to network architecture and optical projects. But the green boxes here then show how they were closely linked in with activities in those similar areas that were already going on within the Géant project. So we structured it in such a way that they were really embedded into the project, but it's not just a case of dividing up the new cohort of partners and the way they do their work. It's not simply just a case of doing that. It takes a lot of other coordination, and so key to that was a set of technical coordinators, as we called them. So these were people, again, who were already involved in the Géant project, technical experts, who each of them were assigned one or more of these new open call projects, and they were the kind of direct technical liaison between the project and the people and the overall Géant activity. And so they were really a key bridge between the new partners, shown there on the right, and the project represented by these technical ambassadors and coordinators here on the left. So there was a lot of work to go on there, by the way. We had something like 137 internal milestones for these guys to check up on, 37 internal deliverables. And as a result of this, essentially, we ended up spending 94% of the budget for the open call. Right, so what I want to do now is to dip into a few examples from the projects. You remember there were these 3 overarching themes, and I've pulled out an example here of one of the projects from the using facilities theme, hence the icon of the data center in the top corner here. That's just meant to indicate which of the themes matches up with the pictures earlier on. Anyway, so this was called DREAMER, which stood for Distributed Resilient SDN Architecture Meeting Carrier Grade Requirements. Some of the acronyms here were particularly inventive, but this is always the case with such projects. So this was an Italian project. The partners were GAR, the Italian research network, CreateNet, which is an SME based in Trento in Italy, and CNIT, which is a consortium of Italian universities who have interests in telecommunications research. It was really all about using SDN to provide carrier-grade services that would otherwise traditionally be provided by an IP-MPLS network. So this is replacing an IP-MPLS control plane, with an SDN-based one, and making sure that it provides resiliency, fault management, and so on. The project had 2 dimensions: a scientific one, which is essentially trying to consider how SDN could be used to provide a resilient system, and an experimental one, which was whereby they were sort of having designed a solution, then experimenting with it using some of the Géant testbed facilities that we have at our disposal, especially the SDN-related one. The services they were considering in this particular project were point-to-point virtual lease line over IP and a layer 2 pseudo-wire service. Interestingly, from this project, they were using the ONOS, the Open Network Operating System, and because that inherently has with it a sort of a high carrier grade, a high resilience, high reliability open source software, but they were adding to this as well, and so they did a few things. As part of that, they exploited the ONOS controller, but they also contributed to it with something that they call Icona, which was, just get my notes up here, an inter-cluster ONOS application. They also developed the notion of a hybrid node, OSHI. So this is where they have an open source implementation of a hybrid IP, MPLS, and SDN networking node. That's what this diagram at the top right is indicating. They developed experimental tools to management tools they called Mantu, which included a nice web front end called Topology 3D. And they also, like I said, they were using the test bed. But the point here is that they have taken contributions to the ONOS system, which I kind of find very valuable. So there's actually impact here. And another nice result is that they're continuing to use the Géant testbed facility at the end of all of this, despite the fact that the formal funding of the project has finished. And results from this particular project are actively being taken up in GN4 in one of the joint research activities. As part of this week, it's the it's the ONS event, it's the which is going on this week, and that they are going to be showing this a demo in essence of their results here, again using the GTS, the Géant testbed facility, and the GTS, the people who run the GTS, Jerry Sobieski from Norginet and others, they put a great deal of effort into supporting this particular demonstration on the facility. So that's one of the projects. Next one I want to talk about comes from the Trust and ID, comes from the Focused Research and Development theme. So this is in the area of Trust and ID, SENSE, which stands for Secure Enterprise Networks Finally Made Simple and Easy. So the partners here were actually two of the NRENs. By the way, the NRENs themselves were allowed to bid into these, into the open calls, and so some of the partners, not a huge number, but some of the partners were NRENs. So this was essentially try and improve enterprise Wi-Fi authentication by making improvements to the EAP, that's the Extensible Authentication Protocol supplicant that you need on a device in order to be able to access EduRoam services. So one of the inventions that came out of this project was that they devised a multi-platform config file format for EAP parameters and took that to the IETF. So there are two drafts actually of this in the IETF. They went with one draft based on XML, and after feedback in an IETF meeting, they went with another draft based on the Yang description language. They defined metrics for assessing how well these supplicants actually work, and found out that a lot of the supplicants out there don't work too well, as it happens. They developed what they call the EAP Lab Toolkit for doing conformance testing of these supplicants, and then they have created two supplicants of their own, one for the Android platform, and that's what's shown in this picture here on the right, and one for Linux. And here's a third example. So this is now coming from the open innovation theme. So there are three projects that came in on this sort of wildcard theme. This one is called COCO. It stands for On-Demand Community Connection Service for e-Science Collaboration. This is, again, it's an SDN-focused project, and it's about trying to provide flexible connectivity solutions, VPN-like solutions, based on SDN. So the partners involved were SurfNet, particularly Ronald van der Pol was driving this, and TNO, which is a sort of a research organization which has come out of what used to be KPN Research Labs. So they looked at on-demand multi-point layer 3 VPNs, and they addressed a particular use case as well, a particular e-science use case, which is a DNA sequencer as a service, as they called it. So whereas Dreamer was addressing the ONOS open source software collaboration, this was looking at Open Daylight, which is another SDN controller ecosystem. So they used and they contributed to the Helium release of Open Daylight. So things that they did were to develop an automated user-level test environment for the VPN. So once the VPN solution is in place, they could stress test it, and they created a mini-net-based simulation. And now, with Ericsson, they're taking some of the outputs from this project and taking them forwards. And the plan at the moment is that some of this will be in one of the upcoming releases, the lithium release of Open Daylight, as part of the way in which it provides VPNs. So, quick dip into a few more of the projects. Obviously, I can't look at all of them, but I'll try and cover some of them. So, another one that came from the trust and ID space was Géant Trust Broker, about building dynamically building trust relationships in the R&E community using new federation services and protocols. This is the Leibniz Research Centrum who did this work. Interestingly, this one now has led to some of the people who are involved in this have now become a task within the new GN4 project. So one of the key people here has become a task leader in the GN4 project. Another one was called Eros. This is all about content delivery networks based on the concept of active networking, in which a content delivery network is dynamically established or optimized for a particular application and then torn down at the end of it. So this was the University of Perugia in Italy and a related biology institute nearby, because their application was genomic. This was a CDN for genomic data. ICOF, this is one of the two projects which used spare optical fiber we had in the network. So this was about comparisons of very accurate optical clocks maintained by standards agencies, in this case, one in London by the National Physical Laboratory and one in Paris from the Observatoire Paris. And so again, they used existing fiber infrastructure. This was an example of a project where the technical coordinator had to work very hard with them. Nicole mentioned you couldn't just hand over fiber and wish them good luck. This was certainly a case of that, because it took a great deal of effort from the technical coordinator to translate their requirements into what could be provided by our underlying fiber provider. IRENA is about investigating the RENA, the recursive internetwork architecture in the NREN space. iMind, TSSG, some other company, NextWorks, and I2CAT were involved in that. Dimitri, I've seen, is sat in the room here from iMinds. Minerva was a project about high availability network transport using the technique of network coding. BME here is the University of Technology and Economics in Hungary, in Budapest, and I2CAT were involved here. Classy is another trust and ID related project from the universities of Mercia and Kent. So this was really about bringing federated ID into OpenStack, was the big thing they were doing there, to the cloud infrastructure OpenStack. And there's a session going on as we speak, actually, this morning. So Professor David Chadwick is talking about that. DINPAC, finally, another SDN-related project, and there's a session on that tomorrow. This afternoon, in fact, in session 5C. So this is the University of the Basque Country. And again, this is an SDN-related one. It's bringing SDN together with path computation element technology. Okay, so one of the original objectives here was to raise the awareness of the Géant project around the world. So what we show here is that we ended up with something, and this was slightly unexpected as to how successful this was. We ended up with people presenting being at more than 100 events, more than 40 scientific papers produced from this work, some of them in quite prestigious journals, 3 IETF drafts, two standards into the Open Grid Forum for the NSI, for the Network Service Interface Protocol, and so as you can see here, collaboration in many of these events and bodies. So what did we learn, really? So we learned that the holistic, we called it the kind of holistic management framework, really making sure that they were integrated into the project. We learned that really was quite key in producing some of the innovative outputs from this project. And by opening up the box we brought in new blood, made work partners who wouldn't previously necessarily have worked together, incentivized them to work together and produce some innovative results. How about sustained impact? Okay, then, well, what we have now is that testbed users, many of them, 5 out of the 6 projects, in fact, are continuing to use the testbed facilities we have. And one of them, well, an example of that is that the people who did the frequency distribution project between London and Paris on the dark fibre, they have plans to continue using that dark fibre, and they'll start to pay for that, to pay to access to that themselves. And many of the projects, like I said, are continuing to use the testbed facilities as we move forwards in the shape of what we call the Géant testbed service. So here's a couple of examples of the sustained impact of the project. So here's a quote here about the SENSE project, when I talked about the improving the environment for EAP supplicants in Edurome. So the quote here from one of the reviewers was the impact of this project is very significant. This is an example of the talent spotting element of what we've done. So this is Daniela Pohn. So she has now, from Leibniz Research Zentrum in Germany, so she now becomes the leader of the task called Géant Trust Broker, which has continued on from this work and is funded in GN4, the first year of GN4. So in conclusion, we think that the results of the open call have really rippled throughout the project. And essentially, we believe we've added significant value to the Géant community through this. And this is not just my words or Annabelle's words. So here are some endorsements from the 3 current JRA leaders in the project. You'll find them in a special edition of the Connect magazine, which is available around the conference. And so don't forget, these were the people that initially would have said, well, why we have got to bring these people in? We've already got our own people doing this. But they found a great deal of use from having the new partners closely engaged in their activities. So the holistic support framework that we put in place really enabled all the partners to exceed our expectations. And finally, that the project has delivered lasting benefits. So in essence, 75% of the work that went on during the open call projects is in some way going to continue, whether that's the nature, the people working, or whether that's some of the results being taken up. But in essence, 75% of that work continues as we move forward in GN4. So with that, I should like to thank you for listening, and myself and Annabelle will take any questions you might have. Thank you.
Hi, I have 2 very practical questions. One is that now I find 2 Edurome applications that play the Android store. So the cat is the old one, and the new supplicant is the non-cat one. Is that right?
I'm afraid I don't know the details of that.
Okay.
I mean, as I understand it, what they have produced is a supplicant which is used as part of cat. So I mean, I don't know there's any conflict there.
And the second question is, for you to keep track of this impact success, was it contractually arranged? So participants would have to state or communicate with you which events they went to, what papers they were publishing. So this follow-up, was it? How did you achieve this?
So Annabelle could probably give a better answer than I can, but they were essentially brought into they had to sign up to the same consortium agreement as everybody else for Géant. I don't know that we contractually obliged them to go to X events. Yeah.
If they were going to an event, they wanted to tell us about it. Because obviously when they signed up, we have to make sure that all the right logos are there, etc. I think the element that surprised us most was when we put this together, we were very specific about what we wanted the impact of each of the projects to be. But I think we had underestimated how far-reaching those were going to be in terms of IETF drafts, etc. And there's a lot of work around standardization which we just hadn't expected, because as Michael was saying, when you bring in new researchers that we've really not worked as closely as perhaps we should have had it in the past. And these are new sets of people bringing in the ideas, their processes, the way they do things. And remember, they've also got different ticks in the box. So for a researcher, they want to be going to conferences, they want to be writing the papers. And perhaps researchers within the traditional GEON community have had different drivers. So that's been really interesting to see the two drivers working together and really bringing in some really significant benefits to the project. So yeah, we've been really, really pleased with the outcomes.
So thank you, Michael and Annabelle. And so we are closing this session. Just a few announcements. Posters are on display in the exhibition area during the afternoon coffee breaks today and tomorrow. And the presenters will be there in these days. Demonstration schedule, there are the demonstration schedule in every break, and you should check online which ones are taking place. The Birds of a Feather and workshops this evening are also in the program, so please join them and make the most of it. It's very important also, I'm being stressed in this point very frequently, to give your feedback regarding each session. You can do it online or in the TNC site. The gala dinner tickets are still available at the registration desk. And the schedule for the shuttle bus for the gala dinner will be announced today via email. So thank you very much to all of you and to the presenters for this session. Thank you.